Right, welcome to redox reactions. So in this page, we are going to be writing half reactions and identifying the species being oxidized and reduced, and the reducing agent and oxidizing agent. All right, let's get started. All right, so you should have your periodic table because we're going to need to be able to assign oxidation states, right? That's going to be our first task. All uncombined elements, right? So hydrogen here is an uncombined element that has oxidation state of 0. Oxygen, uncombined, oxidation state of 0. Now hydrogen and oxygen in a compound, the sum of the oxidation states is equal to 0. That means that oxygen, going to my periodic table, oxygen, -2. That means that each of these hydrogens must be a +1. So then now if you're struggling with the oxidation states, make sure you go and watch the video on assigning oxidation states. Check your notes, stay after for extra help. Assigning oxidation states is very important because using these oxidation states, we're going to determine which ones are oxidized and which ones are reduced. All right, so now let's see. Hydrogen, in this case, goes from 0 to a +1. So that means the oxidation number increased. Right, so the oxidation number increases, so that means that this is oxidized. So we'll just say ox for oxidized, right? Oxidation number increases in oxidation. And then again, lose electrons, oxidation, right? So lose electrons, oxidation, gain electrons, reduction, right? Leo the lion says grr. So then if this one's oxidized, then this one is obviously reduced. Right? One's oxidized, one's reduced, and we're only looking at the reactants. We need to look at the products to see what happens, but the oxidized and the reduced are always reactants. So oxygen goes from 0 to -2. So that means the oxidation number decreased, it goes down. That means reduced. So then that means that the hydrogen loses electrons and, right, lose electrons, LEO. And then the oxygen gains electrons. So when we write our half reaction, I'm just going to write that here. So oxidized half reaction, and we're going to write a reduction half reaction. So our reduction half reaction, right? We're just going to split up this reaction into 2 separate reactions called half reactions. So now let's just talk about our reducing agent and our oxidizing agent really quickly. All right, so the oxidizing agent is the one that's reduced. The one that is oxidized becomes the reducing agent. I like to think of it like secret agent and you switch identities. So ox then becomes the reducing agent. And then reduction becomes our oxidizing agent, right? Secret agents, flip identities. All right, so to do our half reactions, what I like to do is I like to take the element and write down where does that element start. Hydrogen starts, and remember, so this is a diatomic, so we have to keep that subscript, only with the diatomics. And then I'm going to draw an arrow. So hydrogen goes from H2, and it's going to go to a +1. And now I want to balance my charge. And I'm not sure why there's a, let me see if I can erase that. All right, let me just redo that over there. Okay. And there we go. Okay. So hydrogen is going to go to that +1. And so I have to have the conservation of mass. So I need 2 of those +1s. All right, so hydrogen goes from 0 to +1. So then from 0 to +1, and I know Leo the lion says grr, so that means I need to lose electrons. So I'm going to put my electrons on the product side, right? So losing electrons, right? So -1s. So now how many -1s, how many electrons are lost, right? I have 2 hydrogens that are each +1, so they each totally lose 2 electrons together. And so your charges should be equal on both sides because we have the law of conservation. Matter, energy, and charge are always conserved. If I have a 0 charge on this side, I have to have a 0 charge on this side. right? So 2 positive ones cancels out the -2. So now let's draw our reduction, right? So our oxygen is going to be reduced, right? We always show the loss on the product side. We're going to show the gain on the reactant side, but it also balances it by charge by adding -1s. So here I have, I'm going to start off where I started. I start off with oxygen, right? And so since it's a diatomic, I keep the subscript and it has a charge of 0. Next, I'm going to draw my arrow. And what does oxygen end up doing? Oxygen ends up as a -2 charge. It ends up as an ion, right? Remember, the ion doesn't get the subscript, right? This is the neutral. So then how many of those? I have 2 -2 ions, because now I have to balance it, that charge. The diatomic ones are the hardest ones, by the way. If you can do a diatomic, I think you could do any half reaction. So now I need to balance the charge, but I know that gain electrons reduction. So to gain electrons, that's going to go on the reactant side for adding electrons, but balance it by charge. I need to have the same numerical charge on both sides. So I have a 0 over here right now, and I have 2 -2s. So this is a -4. So then now I need the 4 electrons, because I need to have a -4 on this side and a -4 on this side. Remember, the charges don't cancel on either side of the arrow. They have to equal the same total number on either side of the arrow. Sometimes it'll be a 0, sometimes it'll be a different number. All right, so now these are our 2 half reactions. So electrons lost have to equal electrons gained, and now that's where the coefficient over here comes from. And we'll talk about that in another video. All right, so now let's go on to our second. And iron starts off as a 0, elements uncombined. Zinc has got a +2, iron has a +2, now zinc has a 0. So then now I have to identify oxidized and reduced. Iron goes from 0 to +2. I like to just connect them like this. Oxidation number goes up, that's oxidized. Lose electrons, oxidation. Okay, and so then if I'm doing my secret agent thing, right, that means that this one is going to be my reducing agent. All right, now let's go to zinc. Zinc starts as a +2, zinc goes to 0, oxidation number goes down. So then this is reduced. Then that means gain electrons reduction. And we do our secret agent thing. And so the one that is reduced becomes the oxidizing agent. Okay, so I've assigned oxidation states, I've identified oxidation reduction, and I've identified reducing and oxidizing agents. Next comes our half reactions. We have to do a reaction that indicates just what's happening with the oxidation and one that's just the reduction. So now let's look at here, our oxidized. So we're going to do iron. So I'm just going to write down iron, starts at 0. Now I'm going to do my arrow, and iron ends as a +2. Now I have to place the electrons, right? I did identify that losing electrons is oxidation. So that means I'm going to put the electrons over here on the product side, balanced by charge. If I added the electrons over here with this neutral iron, I would have negative, I would end up becoming more negative, and I would never reach a total charge of +2. Remember, our charges have to be equal on both sides of the arrow. So then if I have a 2 -1 electrons, that's a -2 and a +2 equals 0. So iron loses 2 electrons. Now let's do our zinc. So our zinc starts off, in this case, now as a +2. Now I'm going to do an arrow. And now in this case, now our zinc ends up as neutral. And now I have to place the electrons. Reduction is gain electrons. So that means my electrons are going to be added to the reactant side. So how many electrons does this zinc gain? I have a +2, and I have to get down to a 0. So that's 2 electrons. And in this case, electrons lost is equal to electrons gained. So I'm going to stop this video here. And then for number 3 and 4, I'm going to do a separate video because my planning period is done and the bell's about to ring. And so I will either combine this video or there'll be 2 separate videos for this section of half reaction.